Question number 5. A circuit contains a large inductor and 2 light bulbs are shown in the circuit. When switch 2 is closed, when switch 1 is closed, the light bulb in series with the inductor lights up more slowly than the other light bulbs. This one here lights up more slowly than this light bulb here, and the question is why? Initially, when this switch is open, there is no current. Okay, so neither of the light bulbs is working. When we close the switch, it pretty much goes from zero current to maximum current going through this light bulb down here. Okay, and so that lights up essentially immediately. However, when that switch 1 is closed, current begins to flow from its zero to its maximum value. Okay, so there's this idea of this changing current. From this formula here, we can see that magnetic field B is directly proportional to current, i.e. when the current's increasing, the magnetic flux is increasing, because magnetic flux is equal to magnetic field times the area that field's in. So I is proportional to B is proportional to magnetic flux. So what's happening in the circuit is there was initially no current, and now that current is building up to a maximum value. Now as that current is changing, we're getting a changing magnetic flux. A changing magnetic flux induces a voltage. Now you see here there's a negative sign. Okay, Lenz's law makes it a negative sign, so essentially this here becomes a little sort of baby power supply. Okay, and so it makes a voltage in the opposite direction, so it makes, essentially reduces the current, or it prevents the current from flowing, because we know that current equals voltage divided by resistance. Okay, and so as the current's beginning to build, it's creating a changing magnetic flux, which creates a voltage in the opposite direction, which essentially prevents the current from flowing. However, the flux will continue to increase and this change will decrease, and so the voltage that's created across here will essentially disappear, and once it hits a steady current there will be no induced voltage, and the light bulb will go. So what happens? There's no current. The current begins to build. As the current builds, it creates a magnetic flux, and that's a change in magnetic flux because the current is growing. A change in magnetic flux induces a voltage in the opposite direction to the power supply, which prevents the current from flowing and prevents the voltage being lost across this this light bulb. We can see that in action in this animation over here. Okay, we've got our switch 2 closed, and we turn the switch on, instantly bright. It takes a little while to brighten up. Let's see that again. I close the switch, instantly bright. It takes a little while to brighten up. Now if I close the switch, okay, there's energy stored in this inductor, and it takes a little while to go down, a little while to go up, a little while to go down. What do you think happens when I open the switch? Okay, well obviously no current goes through that second light bulb. Okay, and again it takes a little while to go up. However, when I undo the switch, okay, initially it's got a flowing current, okay, and so it's got a magnetic field stored in this inductor. But as soon as I turn that switch off, I'm pretty much turning that current off instantly. Okay, and so that time is really, really short, so I'm going from a full magnetic flux to a zero magnetic flux. So there's a big change in a very short amount of time. I get a massive voltage in the opposite direction to what it was going, and so I'm essentially making a huge voltage. Okay, and pretty much what happens is I blow up every component in the circuit, and that's called a back EMF. Okay, and you'll learn about that soon. Well, what type of answer might you expect to be able to give for this sort of question? Well, the light bulb with the inductor lights up more slowly because as the current changes through the inductor, as the current's growing from zero to maximum, a back EMF is produced. Okay, so that's from Faraday's law, that voltage is equal to negative change in flux over change in time, which opposes the current producing it. This causes the forward current to build up more slowly, then up to its maximum steady state value. Once it's at steady state, there's no changing flux, and so the light bulb will go fine. Okay, it's only when there's a changing magnetic flux is when there is an issue.